Thank you in advance to the overwhelming majority of you who have submitted this homework on time. In general, the quality of your answers was very strong, but I think it's really important that we are all reviewing our understanding every time we do something like this, particularly something that is a summative test of something you learned several months ago. So we're going to go through each question in turn. The diagram on the right is a velocity time graph showing the motion of an object over a period of 7 seconds. And you're given that graph for questions 1 and question 2. Which of the following describes the motion of the object between points A and B? You can see that the velocity is increasing, so it must be speeding up. If it were not moving, it would have to be a horizontal line through y equals 0. If it were moving with a constant speed, it would have to be a horizontal line that wasn't through y equals 0. And if it was slowing down, it would be the line CD, the velocity decreasing. Second question, the total distance travelled by the object during these 7 seconds. The area under the graph is velocity times time, which is distance. This is a trapezium, so I'm doing a half a plus b times h. So that's a half 2 plus 7, so 4.5 times h, which is 6. 4.5 times 6, 27 metres. Question 3, the diagram below shows the graph of y is equal to f of x. Use the graph to answer questions 3 and 4. Which of the following is the equation of f of x? And I'm given these options here. I notice it's a periodic function, so that eliminates my cubic straight away. And then I just use known values. It's the shape of cosine or sine. I know that cosine 0 is 1, whereas sine 0 is 0. So it must be cosine x. Question 4, f of x equals 0.6 has 2 solutions within that domain. Given that one is 53.1, find the other solution. If I draw that on there, that's f of x equals 0.6. I know this value here is going to be 53.1 on the x-axis. And therefore this value here will be 360 subtract 53.1, because it's a symmetrical graph. So 360 subtract 53.1 gives me 306.9. Lots of you needlessly rounding that to 307. They're clearly looking for you, because they've given their answer 53.1, they're clearly looking for you to use that, so keep all precision there, so the examiner is absolutely clear you know what you're talking about. Next question. The path of a river is modelled by equation n equals a over e. So that's an inverse proportional relationship where n is number of miles north of Cross Road, e is number of miles east of High Road. They've drawn that for you helpfully. Work out the value of a in the model. I'm just going to pick any point and I'm going to substitute that into my equation. So I'll pick m, because that's nice and straightforward. So that's e is equal to 2, n is equal to 5. So 5 equals a over 2, so a is equal to 10. If I wanted to check my answer, I could pick another point. Let's say, for example, there aren't really any nice points on here, but let's say that I want e to equal 4. So when e equals 4, I have n is equal to 10 over 4, 2.5, and that does seem to be what's showing on my graph. May is at the river at point M marked on the diagram. Estimate the gradient of the model at May's location. If you're estimating an instantaneous gradient, you draw a tangent to that curve. So I'm trying to just touch the curve. I'm not trying, there we go, I'm not trying to cut through the curve. There is a large tolerance on this because it is hard to get you all to draw the same tangent, and the exam board appreciates that. I've drawn my tangent as large as possible, basically spanning my axes, because it makes my life a lot easier. And then I have my gradient is change in y over change in x. Now there were lots of errors when I was going through this in the sign of your gradient. You must be consistent. It doesn't matter which point you start at. I'm going to pick extreme points, a or b, but you must do ya minus yb over xa minus xb, or yb minus ya over xb minus xa. If you have a positive value for this gradient, it's both obviously wrong, because your gradient is negative, it's decreasing. As x goes up, y goes down. But also, it's because you haven't accounted for that. So I'm going to do yb subtract ya over xb subtract xa. So, if I look then, yb is just 0, and YA is 1, 2, 3, 4, 5, 6, 7, 8, 9, so 0 minus 9. Then XB looks to me to be 4.8, and XA looks to be about 0.4, so I have minus 9 over 4.4, which is, minus 9 over 4.4, which is minus 3 SF 05. And then it won't have any units because it's miles divided by miles. I believe the mark scheme allowed anything between minus 2 and minus 3, so I'm just in my tolerance there, actually. Question 7. May walks away from the river towards High Road in a straight line that is perpendicular to the river, so we're at M. Determine algebraically how many miles she is from the intersection when she gets to High Road. So, just help me visualise that. I'm going to draw a line that appears to be roughly perpendicular. I'm just going to make that dotted. And so what I'm looking for then is this distance here. So the distance between my origin, that's where the roads are crossing, the crossroads, and where she's going to reach. Now it says determine this algebraically, so I need to find the equation of this line. It's perpendicular. I'm going to write in the form y is mx plus c, where my gradient is the negative reciprocal. So that would be minus 1 over minus 2.05. So minus 1 over minus 2.05, which is 0.488 to 3SF. So y is equal to 0.488 x plus c. I know it goes through the point M, and therefore I know that when x is equal to 2, y is equal to 5. So 5 is equal to 2 times 0.488, 0.976 plus c. So c is equal to 5, subtract that number, which is 4.02. And so y is equal to m, so 0.488x plus 4.02. And this distance here, you can see, is just your y-intercept. So she is 4.02 miles away. And once again, you will have different gradients and therefore different answers here. But as long as you applied this method correctly, you would get full marks for that. And so I think relatively simply then, that's 12 marks sorted.